Okay, the next bit today is on Newton's laws of motion. Now, you've already covered these last year, so a quick recap. First law is a body will stay at rest or maintain a constant velocity unless a resultant force acts on the body. The second one is that the overall resultant force acting on the body is equal to the mass of the body multiplied by the body's acceleration. And sometimes you write this as F equals A. Now, if you remember back when we were doing friction, we sometimes call it friction F as well. So you need to decide what you're going to use when you do these questions. Don't get confused with the resultant force and friction. Pick a letter and stick with it. And the third one, for two bodies in contact with each other, the force exerted by A on B is equal in magnitude but opposite in direction to the force exerted by B on A. Right, let's do one really quick, easy example of this then. Okay, you can pause this to copy it down, but a particle of weight 18 newtons is being pulled along a smooth horizontal surface, so there's no friction here, by a force of 7 newtons acting at an angle of 25 degrees to the horizontal. Find the speed of the particle after 3 seconds given that it starts from rest. So, your diagram here to begin with, we know we've got a particle of weight 18 newtons. So we've got a force down here of 18 newtons. It's going to have a reaction force sitting on the ground, and it's pulled along a smooth horizontal surface by a force of 7 acting at an angle of 25 to the horizontal. So if I imagine that's the horizontal, I've got a force here of 7 newtons where that angle is 25 degrees. And it's moving along. So if it's moving, it's going to be going in that direction by A. So I'm going to draw that just to remind me that it's moving with that. And then there's no friction, so I just need to resolve this force. So this force here will be 7 cos 25, and I'm going to have a force going up, which will be 7 sine 25. And I'm going to look at motion going this direction. So resultant force in that direction is just 7 cos 25, and that's equal to mass times acceleration. So that must be equal to mass. Now we're told that the weight's 18, so the mass must be 18 over g times A for the acceleration. So that's my formula, and then I just need to, from that, work out A, so I can divide by 18 over g, and that should come out to give me that A equals 3.454 meters per second squared. And then I need to go back to what we did at the start of last year. It says find the speed of the particle after 3 seconds. So we need to use suvat. So we need to use our suvat equations. And what are we told? We're told it starts from rest, so u is 0. I know my acceleration is 3.454. I know that the time is 3 seconds. And I want to find the speed, so I'm trying to find v. So, which equation has u, v, a, and t? It's going to be v equals u plus at. V equals 0 plus 3.454 times 3, or v equals 10.4 meters per second. Right. If you're happy with that one, have a go at page 445. Exercise 3.1, and there are 3 questions on that. Have a go at those 3 questions.